my dear students, in the previous session we had discussed about the decomposition reaction along with many examples. In the today's session we are going to discuss about the displacement reaction. Yes, we are going to understand here what do we mean by displacement reaction. See here, the reaction in which a more reactive element displaces another element from its compound is called displacement reaction. You should not memorize this definition. You have to understand this definition. Yes, in this type of reaction, what happens? The more reactive element will displace another element from its compound, because of which we call this reaction as displacement reaction. Let me write the general form of the equation for this reaction. Suppose A is a metal, reactive metal, and BC is the compound containing another metal B here, which is less reactive than A. A being more reactive than B will displace B from this compound BC to form AC plus B. Now A is in the place of B in this compound. You can see here in the product. So it has displaced B from this compound, because of which we call such reactions as displacement reaction. The important thing which you have to note here is, for A to displace B, it should be more reactive than B here. Then only the displacement reaction takes place. Yes. Now we will see few more examples here along with the activity. First, let us discuss about the displacement reaction between copper sulphate solution and iron. Clean 3 iron nails using sandpaper so that the greyish color of the iron is clearly visible, and if there are any impurities on the outer layer are also removed. Iron is grey in color. Yes. Take 2 test tubes marked as A and B. These are the 2 test tubes taken. This is A and this is B. In each test tube, take about 10 ml of copper sulphate solution and tie 2 iron nails with a thread and immerse them carefully in the copper sulphate solution in test tube B for about 20 minutes. We have to take 2 iron nails and we have to immerse in the test tube B. Note, we are not dipping the iron nail in test tube A. This test tube A is taken for reference to observe the initial color of the solution, that is copper sulphate solution. We are dipping iron nails only in this test tube. Now, keep another one iron nail aside for comparison. We have taken another one iron nail in order to compare this color, initial and the color of the iron nail after the reaction. After 20 minutes, take out the iron nails from the copper sulphate solution. Those iron nails which were dipped in the test tube B are taken out after 20 minutes. Compare the intensity of the blue color of the copper sulphate solution in test tube A and B. This is the test tube A, where we have not dipped any iron nail into this solution, and in test tube B we have dipped the iron nails into this solution. After 20 minutes we will observe the color change in this test tube, that is the color change of the copper sulphate solution. Also compare the color of the iron nails dipped in the copper sulphate solution with the one kept aside. We have to observe the color of the iron nails dipped in the solution, that is copper sulphate solution, with the another nail which is kept aside. Yes, what are the observations that we make here? The nails taken from the test tube B turns brownish. The nail which is taken out from this test tube has turned brownish now. The color of the copper sulphate solution fades from being blue in color initially. The color of the copper sulphate solution is blue. You can see here initially the color of the copper sulphate solution is blue. Once the reaction takes place, the color of the copper sulphate solution starts fading, because there is a reaction taking place between iron and copper sulphate solution. Now, why is the color change that is observed here? Because the element iron in solid state reacts with the compound copper sulphate in aqueous state and gives aqueous iron sulfate and solid copper. You can see here the brownish deposit on the iron nail is because of deposition of the copper metal. There is a reaction that has taken place between the iron and copper sulfate solution. Iron has displaced copper from its solution, because of which the color has faded away. The color of the copper sulfate solution is blue color, but now there is no copper sulfate solution. The iron has displaced copper from its solution to form iron sulfate, which is green in color. The color of the copper sulfate solution fades from being blue in color initially to green color. This green color is due to formation of iron sulfate. So, the conclusion that we can draw from this activity is the element iron, being more reactive, displaces copper from its place in copper sulfate reactant and forms the product iron sulfate. So, let us write the reaction here. We have taken iron, which is in solid state, reacts with copper sulfate solution, which is blue in color, form. This iron has displaced copper from its compound, that is copper sulfate, to form iron sulfate. And copper is deposited on the iron nail. You have to mention the name of the reactants and products here. This is iron, this is copper sulfate. You should remember the color of these solutions before the reaction and after the reaction, because many a times in your examination you have to mention the color change if they ask you about the observation. Yes, it is blue in color. Then iron sulfate is formed, which is green in color, because of which the color of the solution has faded away from blue to green color. This is green. As you know, this is copper. Hence, in a displacement reaction, the more reactive element displaces less reactive element from its compound. But how to remember which metal is more reactive and which metal is less reactive? It is by using the activity series. By using activity series, we can find the relative reactivities of different metals. By using the reactivity series, you can easily remember which element is more reactive and which element is less reactive. And the element which is more reactive can displace the less reactive element from its compound. This reactivity series has been developed based on the different reactivities of metals towards oxygen, water, acids, etc. As you move down this series, the reactivity decreases. So you can say that this potassium is most reactive. And as you move down, you can see here gold is very least reactive. And here hydrogen is also placed in between these metals, that is lead and copper. This helps us to know whether these metal can displace hydrogen from acids or not in this way. And it is very important to remember this activity series. Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, gold. You have to remember these metals in order. And in between, there comes the metals of moderate reactivity. As you go up, you can see the most reactive metals, and in the middle, there comes the metals of moderate reactivity, and at the bottom, you can see the least reactive metals. Any metal which is placed above in the activity series can displace another metal from its compound. For example, this magnesium metal can displace aluminium from its compound because it is placed above in the reactivity series. So it's important to remember the reactivity series here. Let us see few more examples for displacement reaction here. For example, zinc reacts with copper sulfate solution to form zinc sulfate plus copper. Because zinc is more reactive than copper, it will displace copper from its compound. Another one example, lead plus copper chloride solution. Lead displaces copper from copper chloride to form lead chloride plus copper. If I write Ag, that is silver, zinc sulfate, what is the product formed here? My dear students, observe that silver is less reactive than zinc. The silver comes in the bottom in the activity series, whereas this zinc is the most reactive metal when compared to silver here. So this cannot displace zinc from this solution. So what you have to write here, no reaction takes place, because many a times in your examination they will mention the reactants and you need to write the products there. You have to observe the reactivity series, which element is more reactive and which is less reactive. Then you should write the products. Do not simply write the product just by displacing this element from this compound. You have to observe the reactivities of both the metals here. So this is all about the displacement reaction. In the next session, we are going to discuss about the double displacement reaction. This displacement reaction is also called as single displacement reaction. In the upcoming session, we are going to discuss about the double displacement reaction.